Hey everybody, welcome back. You can probably tell by the title of this video and the motor that's in front of me that this is not going to be a great, happy day, because this motor is my rotary phase converter idler motor, and it's seen better days, and I did not realize how much better those past days were until recently. Because not long after I made my rotary phase converter video, this happened. This is one of the start capacitors, and it completely exploded. It actually destroyed most of the stuff in the control panel these were in, too. That's why they were in a separate box, because I was a bit afraid of them. And this was not actually the first time this happened. The first time I thought it was a coincidence, but the second time I was suspicious of the capacitors and my motor. The capacitors, first of all, because what's with all this extra space in here? It's a dubious quality capacitor for sure. But I was also suspicious of my motor because if there's like shorts in the windings where there's not supposed to be, it can make capacitors pretty unhappy. So I picked up a new device here, a Megaohm meter, or a Megger, they're more commonly called, and this is a pretty neat vintage one. This one, it's vintage military, Navy Department, and I'm pretty sure this was intended for testing coax for like radios and stuff. That's what everything was. But it's a device used to test the condition of insulation on wires, and it does that by measuring extremely high resistances. Like this is in megaohms. That's why it's called a Megger or Megaohm meter. Which is million ohms, and this goes up to 200 million ohms, or infinity. More modern meters can go up to like 1,000 megaohms before they reach their infinity point, but this still gets the job done, because for a motor, the maximum resistance, or I should say the minimum resistance you want between like windings that should not be connected and windings to the chassis is around 150 to 120. I mean, that depends on the motor manufacturer, but since I don't know anything about what the actual spec of this motor was supposed to be, a general rule of thumb is just 150 to 120 is your bare minimum. And, this goes up to 200, so as long as the meter doesn't move much, the motor's in the clear. So, yeah, and this outputs 500 volts at 45 microamps, so you need that high voltage to measure such high resistances. And here, I'm gonna put this down for a second. If I short these out, this is the output right from there, and I turn on the output, it's not always on. That goes straight to 0, and 0 ohms is 0 resistance, or maximum conductivity. Whereas if I disconnect these two, I'm gonna put this down again, then they're just on the dirty carpet, not doing anything, and turn it on, the meter doesn't really move. It jumps a little bit as because of the capacitance and crap in the wires or whatever, but really there's no connection there, so that's infinite ohms, or like no conductivity whatsoever. So 0 is maximum conductivity, infinity or 200 is minimum conductivity, and what we want for all of these tests here is the minimum. We want this needle not to move at all. So I drew up a little diagram here. I poked around at the continuity tester with my motor, and excuse the bad drawing, but just messing around with these taps here on the motor, I think this is kind of the layout of the coils here. We got the center delta in here is 3 coils, and then the 3 outer coils can be wired either in series with this coil for high voltage operation or in parallel for low voltage. And I drew these very faint lines here because I had them wired in parallel to run on 240, not running on 480. And so you connect these outer points together, and you connect these to the inner points, and you feed power in to each point here, and then these 2 coils are then wired in parallel, which makes sense because you'll see when you run it on twice the voltage, it's half the current, whereas if you run it on half the voltage, it's twice the current. So you have to double up on your coils if you're running on half the voltage, whereas with running on twice the voltage, you can spread out your coils more, and you also need to, because they need to be longer to deal with the more voltage. I don't need to get into that, but the main thing is here, where I've drawn these faint lines, since I have everything disconnected here, there should be no connection. So there should be no connection between 1 and 7, no connection between 9 and 3, no connection between 8 and 2, no connection between 5 and 6, etc., etc. And there also should be no connection between any of these wires and the chassis of the motor. And I guess that's a good point to start here. So if I just hook one of these clips up to this eye bolt on the top of the motor, and I can just pick a coil here, it doesn't really matter. Let's pick that wire there. And now if I turn this on, remember we want the meter not to move at all. And that goes straight to 10 megaohms. And that's really bad. Like, that's so bad that I can actually measure that with just a regular old multimeter. I didn't even need to buy this new tool. The worst motor I've seen, personally, I've seen some demonstrations done, and I've never seen them with this low of a resistance. Look at that, 6 there. Like, so, and that's just a chassis. So, like, these are live wires, remember, and that's just the body of the motor. There's a connection there. There should not be a connection. Excuse me. So then, like, the other point is, like, between these two that I duct taped together, we're gonna have continuity because these are one coil here. If I can get everything else out of the way. And you can see that just jumps straight to 0. It's more like 4 ohms, but remember this is measuring millions of ohms, so that 4 ohms really doesn't show up on the meter. And that little gap there between 0 can just be chalked up to just air in the analog meter. But that's normal. But then if we connect, like, between this one, remember there should be no resistance here, except we're reading a fairly high resistance in the megaohms. So this motor is completely toast, and those shorts between these coils in particular are what have been killing my start capacitors. I mean, it runs, which is surprising considering this is how bad this is, but it's barely. I don't know how it still runs. So the rotary phase converter project is going to be on hold. Oh, those are the same. It's like, is there a dead short between 2 coils? No, those are in the same coil. Anyway, that was it. That's a bit how to use a megaohm meter. If you're just testing to ground too, you don't need to unhook all your taps in the motor because it doesn't matter. I mean, even if these were all attached together, we'd still be able to get the same reading to ground. And that if there's anything that shows up on the meter, you've got a bad motor. Sorry about the kind of crappy video here, but I didn't feel like doing much work today. But yeah, I might try, in the future I'm planning on doing a transistor-based phase converter, which might be significantly better than a induction motor-based ones. I think I'll have a hard time finding another motor of a similar size for money that I want to spend on this. So yeah, we'll see. It's a hiccup, but I'm not going to completely give up on this project. So that was all I had for you today. Thanks for watching, and see you next time.